This question uses statistical tests to investigate whether advertising leads to increased profits for a grocery store. Emika is the manager of a grocery store. She is carrying out a statistical analysis on the number of bags of rice that are sold in the store each day. She collects the following sample data by recording how many bags of rice the store sells each day over a period of 90 days. She believes that her data follows a Poisson distribution. Question AI: find the mean and variance for the sample data given in the table. 2 marks. So, number of bags, it's our data, number of days, it's the corresponding frequency. So, using a calculator, we choose Stat, Edit, L1, it's our data, 0, 1, and so on up to 10. And L2, it's a corresponding frequency, 1, 8, and so on up to 2. And then Stat, Calc, and we need one variable statistics. And we get, you can see list, it's L1, frequency it's L2, and we get the result. It's our sample mean 4.23 to 3 significant figures, and sigma, it's a sample standard deviation, and this value squared becomes variance. So variance is 4.27 to 3 significant figures. So we write that mu is 4.23 and variance is 4.27. The next, Hans state why Emika believes her data follows Poisson distribution. 1 mark. Hence implies we must use the previous result, and we know that for Poisson mean is equal to, or should be equal to, variance, and we can see that here they are very close, so we can conclude that she believes her data follows a Poisson distribution because mean is close to the variance. Or you may write very close. And the next question B, state 1 assumption that Emika needs to make about the sales of bags of rice to support her belief that it follows a Poisson distribution. 1 mark. So we need one more assumption, and it may be that the number of bags sold each day is independent of any other day, or the sale of 1 bag is independent of any other bag sold, or the sales of bags occur at a constant mean rate. The next, Emika knows from her historic sales records that the store sells an average of 4.2 bags of rice each day. 4.2 bags per day. The following table shows the expected frequency of bags of rice sold each day during the 90-day period, assuming a Poisson distribution with mean 4.2. So n is 90. Question C, find the value of A, B, and C. Give your answer to 3 decimal places. 5 marks. So we need the expected frequency, and how to find the expected frequency? It's just n multiplied by the corresponding probability, and 90 multiplied by the probability that x is less or equal than 1, and x is distributed by Poisson with mean 4.2, and just using a calculator, 90 multiplied by, and we need distributions, and since it's less or equal, we need Poisson CDF. CDF mean is 4.2 and x is 1, and we get that it's 701823 decimal places, and hence then B, it's 90 multiplied by probability that x is 4. For 1 x, it's PDF, not CDF, so it becomes 90 multiplied by and we need Poisson PDF 4.2 and x is 4. And it's 17.498 and see it's 90 multiplied by the probability that x is greater or equal than 8 and it's 90 multiplied by, I cannot calculate it directly using a calculator, but less greater or equal can be rewritten as 1 minus probability of unwanted events, and we don't need what up to 7, so 1 minus probability that x is less or equal than 7, and it's CDF, Poisson CDF. So it becomes 90 minus 90 times distributions and Poisson CDF 4.2 and 7, and it's 5.755. The next, Amica decides to carry out a chi-square goodness of fit test at the 5% significance level to see whether the data follows a Poisson distribution with mean 4.2. And question DI, write down the number of degree of freedom for your test 1 mark. And for chi-squared goodness of fit, we remember that degree of freedom is n minus 1 and minus 1 for every additional estimated parameter, but here mean is given, so it's known, and it becomes 1, 2, 3, 4, 5, 6, 7, 8, 8 minus 1, 7. I consider this not this table because you can see that there are combined values, and finally we will use this data, and also observed it's also will be less or equal than 1 and greater or equal than 8 here, and you remember that for this test if expected is less than 5, you should combine values, or it means the expected frequency cannot be less than 5. And the next, perform the chi-squared goodness of fit test and state with reason a conclusion, 7 marks. So we write that the null hypothesis is that the number of bags of rice sold each day follows Poisson distribution with mean 4.2, and alternative hypothesis you rewrite absolutely the same, but does not follow. So the number of bags of rice sold each day does not follow Poisson distribution with mean 4.2. And then we need expected and observed frequency. And for expected, it's the same stat, edit, and you can see it's our A, 11 point something, 16, B, and so on, up to C, which is 5.755. And I repeat that the expected cannot be less than 5. And then observed, it becomes, since it's less or equal than 1, it's what? It's 9, and the same values for 2 and up to 7 and 8 or greater, it's 4. So you can see the first it's 9 and the last it's 4. And then so L4 it's observed, L3 it's expected, and then stat, tests, and just choose goodness of fit. And observed L4, expected L3, degree of freedom is 7, and we get P value, it's the probability. Or it's not required here, but in general, how to do that in terms of chi-squared, it's calculated, and it may be given, and actually chi-squared distribution looks like this. It's not required here, but in general, it's another way how to make a conclusion. Chi-squared looks like this, and it may be given critical value, and we compare calculated this value. For example, it's just example, let critical is 4, and if calculated this value is 4.4, it's to the right. It means that probability that chi-squared, this parameter area to the right, it means that it will be in the critical region, so we accept the alternative hypothesis. And if this calculated value, this chi-squared value calculated, is less than critical, it means that probability will be greater than 5%. It means that we reject the alternative hypothesis, or we accept the null hypothesis. Or in terms of p-value, is directly probability. So p-value its probability is p-value is 0.728, and we compare with significance level. It's 5%. It's 5% as 0.728 is greater than 5%, 0.005. It means we accept the null hypothesis or reject the alternative hypothesis. If this p-value is less than significance level, you accept the alternative hypothesis. So we write a conclusion: there is insignificant evidence to reject H0. It means that we accept H0. It means that this H0 is true. It means that in context that the number of bags sold each day follows Poisson distribution with mean 4.2. The next. Amica claims that advertising in a local newspaper for 300 Thai baht, its currency, per day will increase the number of bags of rice sold. However, Nick, the owner of the store, claims that the advertising will not increase the store's overall profit. Nick agrees to advertise in the newspaper for the next 60 days. During that time, Amica records that the store sells 282 bags of rice with a profit of 495 Thai baht on each bag per bag. And question E. Amica wants to carry out an appropriate hypothesis test to determine whether the number of bags of rice sold during the 60 days increased when compared with the historic sales records. Historically, we remember that it was 4.2 per day, bags per day. So the null hypothesis becomes that mean is, and it's per day, and if we consider 60 days for Poisson, mean becomes just 60 multiplied by 4.2. It's 252. It's because we consider a 60 day period. And alternative, it's given that increase, so mu is greater than 252. And question I, by finding a critical value, perform this test at 5% significance level, 6 marks. So it's E, I. And we know that it is sold 282 bags, and again, it's not required here, but to review in general, the first way is since we need greater, the first way is just to calculate p-value. It's probability that x is greater or equal than 282 under Poisson with this mean 252, and you get p-value. And if this p-value is less than 5%, you accept the alternative hypothesis, or there is a significant evidence to reject the null hypothesis. But here we should use another way. We find a critical value firstly, and then just compare if our value this is in the critical value, we automatically accept the alternative hypothesis. If it's not in the critical, hence we reject the alternative hypothesis, and we consider under Poisson with mean 252, and how to find the critical region. So we need such value of x so that x is greater or equal than x is less than 0.05. And actually it depends on calculator. You may consider directly using lower limit, upper limit, but my calculator doesn't allow to do like that. So I say result, I will not explain how it arises, but as a result, how to find a critical region for, it's called upper tail. It actually will be absolutely similarly for binomial. And what should we do? We consider binomial, Poisson CDF, so we need distributions, and binomial using binomial Poisson CDF, and I need the first value which is greater, for which probability is greater than 0.95. It's 1 minus this 5% under Poisson CDF. How it works? And actually it's by trials and errors. I now know the result, so 252 and x. You should try some values, for example 260, 70 and so on. It will be larger or smaller, but I consider 270, or for example you consider 270, and you can see that probability 0.87. We need probability to be about 0.95, and we need the first value which probability is greater than 0.95. And you increase, you may consider 273. If it's too much, you consider some value small and so on. But if we consider 277, you can see that probability is 0.94 and something. And if I consider the next 278, and you can see that its probability is 0.95 and something, and you can see that 278 is the first value which probability is greater than 0.95 under Poisson CDF, not PDF, CDF, with this mean. And hence critical region, we don't take this value which is the first after 0.95, and from 279 and greater, it's the required critical region. And then we just compare our value. 282 is greater than 279, 279 it's a critical value, or we can say that our value 282 is in critical region. And what does it mean? It means that we accept the alternative hypothesis. So we write that there is sufficient evidence to reject the null hypothesis, and in the context the advertising increased the number of bags sold during the 60 days. Or another method, the second method, is to consider sample mean, and historically it's 4.2, and the alternative is this mean has increased or greater than 4.2, and we consider sample mean. And sample mean, what does it mean? It's this 282 divided by 60 days. Divided by 60 days, and it's 4.7. Sample mean is 4.7, and this sample mean is distributed normally, and it arises from the central limit theorem, and it says then when a sample is large, when n is greater than 30, any sample, or it means taken from any distribution, follows or can be approximated by normal distribution with parameters the same mean, but variance is the previous variance, and it's again 4.2 because it arises from what Poisson. For Poisson, mean is equal to variance. It's variance, it's not standard deviation. The variance divided by n, so divided by 60. And standard deviation is square root 4.2 divided by 60. It's variance. And again, the first way, it's not required here, but to review in general, since we need greater, you consider sample mean is greater. For normal, it doesn't matter, included, excluded, greater than 4.7 under this normal. And if, again, it's less than significance level, 5%, for example, you accept the alternative hypothesis, or there is sufficient evidence to reject H0. But here it is required to find the critical region firstly. Oh, sorry, actually, question is to find critical value, as region is less or equal, but critical value, you write just 279. Critical value. And absolutely similarly, but for normal, since its significance level is 5%, so we need such x value so that area to the right is 5%. But using normal, definitely it's much faster and easier. So we need inverse normal and area. My calculator asks me area to the left from given critical value, so area is 0.95 and mu is what, 4.2, and sigma it's a square root square root of 4.2 divided by 60. And we get critical value. Or critical region. So critical region, it's x sample mean is greater than 4.3635 and so on, or critical value is just 4.635, just this value. And then we can see that our sample mean is somewhere here to the right from this critical value. You can see that it's in the critical region. It's greater than 4.635 and so on, or it's in the critical region. So we accept the alternative hypothesis, or there is significant or sufficient evidence to reject H0. And the next question, hence state the probability of type 1 error for this test, 1 mark. And what is the probability of type 1 error? It's probability to accept H1 when H0 is true. For continuous, for method 2, for the second method, for normal, it's automatically significance level is 5%. But for discrete, for this Poisson, the probability to accept H1, it's when probability of x to be what, greater than 279. It's here, it's clear that to be in critical region, so when x is sample mean, or just x is not, for Poisson it's not sample mean, just x is greater or equal than 279. So we accept H1, but under, it's not conditional probability, it's just to show that under Poisson with mean 252. And it is equal to, and I rewrite as 1 minus probability that x is less or equal than what, 278, to use Poisson CDF. So it becomes 1 minus, and distributions Poisson CDF, it's 252, and x 278. Yes, and it becomes 0.0493 to 3 significant figures, and it's the required probability of type 1 error for method 1. For method 2, it's automatically 5%. And the last question, by considering the claims of both Amica and Nick, explain whether the advertising was beneficial to the store. 3 marks. So historically 4.2 per day, and if we consider 60 day period, we can conclude that, and they sold how many? 282, and we can find extra bags sold. So the number of extra bags sold, it's what? 282 minus 4.2 multiplied by 60, but it's our mean 252, and it's 30 bags. And it is given that profit for each bag is 495 multiplied by 30, so it's extra profit, and it is equal to this value. And cost of advertising, it is given that it's 300 per day, so it's 300 times 60 is this value. And we can make a conclusion that the advertising was not beneficial because cost of advertising is greater than extra profit. And actually it can be acceptable that you may suggest that it will be beneficial in future or something like that. It also may be acceptable, but here I can answer like this. And that's all for this question.